go through to the stream.
Okay, let's try that.
Testing.
We're live.
Are we live? Are we good? Okay.
Okay.
Oh, it says, and they're gone. Uh-oh.
I turned it off and turned it back.
Oh, okay, there we go. Wow, imagine that. The solution was to turn it off and on again. We made 0 changes to any of the settings. The mic was plugged in, it was not muted. So apparently, sometimes it's just back to basics. Well, we'll start from the top then. Ladies and gentlemen, thank you so much for joining us this Friday evening, and thank you for sticking with us through the technical difficulties. I think in North America it ranges anywhere from 2 or 3 p.m. to 7 p.m. I think we have some folks for whom it's already past midnight. So thank you so much for sticking with us and for tuning in this Friday night. We have a really fun stream planned for today. As always, please let us know. Thank you very much for the feedback about the audio not working. If you have any other suggestions, if you want things tuned, please do let us know. We have a lot of Mosaic team members in the chat, and we'll be adjusting and trying to make this stream as interactive as possible. So I want to start with what the stream is all about. We'll give a high-level overview of what we are going to cover, and then we'll dive right into the technical side. So the idea for this stream first started because we've had a lot of questions, a lot of technical questions about how Palette 2 works or why something was designed in a certain way. And we thought it would be fun to do a Palette 2 technical teardown where we have many of the engineers who have made a lot of Palette 2's design decisions, and we can walk through a lot of the nuances so you can see what that process was like in designing the product. We'll also have plenty of time at the end for open Q&A. Any questions you have, any comments, concerns, any ideas, anything else you want to chat about or want to share with us, we'll have time for that as well. Okay, some things we're not going to discuss today. This stream is not going to be about product specs or instructions or sales. If you're interested in those, feel free to reach out to our support or communicate to us via our website. Instead, this stream will be focused on 3 things. The first thing is that we're going to be sharing and discussing some of the design decisions, like I mentioned. The second thing is that we'll be showing off some features of Palette 2, some of them that Palette 2 owners might not be aware of. And 3, again, we'll have that open Q&A at the end. So I want to introduce everyone here. On your far left, we have Brennan Coady, who is our Palette 2 hardware lead. Here we have Ali Olia. Ali is our R&D and manufacturing lead on Palette 2. And this is Bobby Wood, and Bobby is Palette 2's firmware and software lead. Okay, so let's get started with a high-level overview of Palette 2. I think most people who have connected to the stream probably have a Palette 2 or are looking to learn more about it. At a high level, what Palette 2 does is it takes in up to 4 filaments at once, it cuts them up, joins them together, and feeds them to 3D printers so that they can print in multiple colors and materials. We're going to dive right in and talk about some of the nuances of the design. So let's jump right in. I'm going to direct this first question to our hardware engineers. One of the first things that people notice when they pull a Palette 2 out of the box is how easy the lid is to remove, and they'll eventually discover that it's held on by magnets. I'd love for you to chat about why are magnets used, what was the idea and the thought behind that, and tell us more about how Palette 2 uses magnets.
Sure, so I can answer that one. When we were designing the system, we really thought a lot about the way that the system is going to be used by our customers. And one of the big factors that we liked was having this be easily, the top casing easily removable so that you can sort of see all of the action that's happening. And when we talked more and more about the way we wanted this, the top cover to fixture to everything else, the concept of magnets came up. And magnets have this really sort of magical feel to them. As mechanical engineers, we view magnets as this like truly magical quality where they, there's something really inventive about using them in creative ways. So we had a prototype and we threw some magnets in it, and it just felt right. It had that feeling of when everything is in the right position, it sort of auto locks itself together. It's really easy to add and take off, and there's something really magical about that feeling.
Definitely. Okay, so that makes sense for the top cover. Where else in Palette 2 do we use magnets and why?
Sure. So there's two other primary places. One is in the cutter.
Okay.
So we have this.
We have another
rotary
camera
cutter.
here.
Yeah. So we have this rotary cutter system. So you can see here, it moves back and forth. And one of the areas that we decided to add a magnet is right here. So when we were designing this cutter system, which I can talk about in a little bit, we decided to put a magnet here for two primary reasons. One, we started with a physical limit switch, and we found that aligning that limit switch and put it in a position where when the cutter rotates, it hit the limit switch reliably was quite challenging. There's some tolerancing issues. And we found that because the cutter has to operate so many times repeatedly, that there were sometimes wear challenges with that using a physical switch. So we decided to use a magnet, and it uses something called a Hall sensor, which detects the magnetism. It allows this sort of non-contact sensing, and it works super reliably. So we found that it's very reliable, has literally zero wear on that part of the system, and it's kind of magical as well. And the other place where it's used is in the scroll wheel in this rotary encoder, which I think we could talk about a little bit later.
Gotcha.
But it's used in a few different ways just due to the it's a much easier system than some of the other options we looked at.
Gotcha. We have Eddie Moser in the chat admiring your accent, saying a true Canadian. Ha ha ha, a boot.
Yeah, I do my best.
Thank you for that, Eddie. Okay, awesome. So let's talk about the cutter a little bit, because so we use magnets in the cutter, but I understand that Mosaic has done a lot of designing cutters. Obviously, Palette and Palette Plus both had cutters as well, but I think this system is a little bit different. So I'd love if you could chat about some of the differences about the cutter and perhaps some of the intricacies of the design.
Sure. So if I can take you way back to when we designed the Palette originally, one of the big decisions that we made was the very large rotary cutter that existed in that system. There's a lot of advantages to having a rotary cutter, and way back early in the history of Mosaic, we also tried something that they affectionately called a guillotine, which is this big blade that comes and chops filament. And something that you'll quickly discover, and people can maybe do this at home, but be careful, is cutting a piece of filament is really difficult. It takes a huge amount of force. And the number that we did a lot of testing, certain filaments are all the way up to 75 newtons, which is quite a substantial amount of force to be applied to a piece of filament. And so
I heard with the first version of Palette that when it would cut, there would be this very distinctive thump.
Yes.
when it would actually get through the filament and hit whatever was underneath it.
Yeah, so that goes back to how much force it takes, and we found that the filament often it doesn't cut; it more digs in and then breaks. And so, doing a lot of testing in different motions and different ways of cutting filament, we discovered a few things. One, that the rotary cutter is probably the most efficient way of cutting filament. It's very small, and using the torque advantages that we get from gearing the systems, using a belt system, we're able to apply a very large amount of force using a very small system. And we've also done some creative design in how the filament channel versus the cutter aligns. And so you get less of a chopping motion and sort of halfway between a slicing and a sort of rotary snap. So it's the analogy we use is like if you're cutting a tomato. So you sort of have this rotary slicing motion. And
it's like dicing with your wrist versus just flat down.
Exactly. Mm-hmm. So it applies less force and requires, it ends up with a lot less wear on the blade. And so your blade lasts a lot longer. And so one of the tests that we did when we first experimented with the system was setting it up to just cut millions of times. Mm-hmm. And we found that the system can last hundreds of thousands, if not millions of cuts before significant wear starts to show on the blade. And it depends on the filament, but with sort of standard PLA filament or ABS or the standard materials that we work with, it's hundreds of thousands, if not millions of times.
Mm-hmm. Gotcha. I saw in the chat someone said, "Who is that speaking?" And that was referring to me. I forgot to introduce myself. I'm Brennan Foo, and I work on the business side of things here. Okay, well, thank you for that, Brendan. That is very interesting. There are a lot of subtleties in the cutter mechanism that are easy to gloss over if you don't take the time to think about all of its intricacies. So thanks for sharing that. When we were talking about magnets, you also mentioned our magnetic encoder. I'd like to chat more about that. For those who might be unaware, our magnetic encoder is also known as the scroll wheel. And Palette version 1 and Palette Plus also had the scroll wheel. And I'd love to dig into that a little bit more because there are differences between Palette 2's scroll wheel and Palette Plus's scroll wheel and Palette scroll wheel, aside from just being built inside Palette 2. So I'd like to, I think, direct this to Bobby.
Sure.
First of all, what is the scroll wheel? How does it work? And why is it important?
Yeah, sure. I'm going to point to it on Palette 2 so that we know what we're talking about. It's hidden under, so this is the very top of the scroll wheel here. And it's this rubber hub that filament passes through. I'll take this out so we can spin it around. There's a, that silver circle down in there, that's the magnet that we use. And it's a very important magnet. Unlike the rest of the magnets in Palette, it is magnetized diametrically. So one half is the North Pole and the other half is the South Pole. As that spins, the poles change, and that uses a sensor that's down below it by just a couple millimeters. And that motion of the poles allows us to detect about 2,000 counts per rotation. So as you can see, if filament was to pass through there, it just spins around, and as that magnet spins, we read that. Do we have a bit of filament by any chance? I don't think so. A really important thing about the scroll wheel is that there can't be any slip. When filament passes through here, this hub has to register all of the movement. So you might be able to see it if I kind of pull on it. But this is actually a rubbery, tacky material as opposed to the rest of the palette that's this hard plastic. That gives us a little bit more advantage on not losing track of any filament there.
It's not dissimilar to the... Oh, well, maybe it is. I was thinking the grommet and the extruder clip. Is it a similar sort of hardness and material here?
Yeah, it's a little bit harder, but similar idea.
Gotcha. Okay, thank you, Mar. Okay, Marsman, I think we're going to switch cameras here. Okay.
So it really is just a magnetic rotary encoder, high precision. But the name scroll wheel, we call it a scroll wheel. It comes from... that goes all the way back through the history of Mosaic. It comes from the idea of using the scroll wheel on your mouse to scroll. The idea of that, your filament being the filament, or your finger being the filament, and moving that to track its motion. So that's why if you see us calling it the scroll wheel, that's why.
Interesting.
Yeah, did I hit all the bases?
You hit on what it is high level, how the sensor works,
why,
but not why it's really important to Palette.
Okay. Yeah. So yeah, Palette does a couple different things. For those of you that don't know, the main thing is, let me see here, splicing, which happens in this area here. Oh, good. So this is what we call the splice core. This is going to probably be covered in quite a bit of depth later on in the live stream. But this is where we actually join the filament. That's one of the main purposes of Palette. The next really important thing is to make sure that that change in color appears at the nozzle of your printer at just the right time. So that is done using this rotary encoder. You'll also see that there's this big region here, which it's really just empty space. We call this the buffer. And this allows us to decouple the production of filament by Palette from the consumption of filament by your printer, because those two don't happen at the exact same rate. So that's why the scroll wheel is so important for us. It allows us to keep track of what the printer is doing, and it also allows us to check in and check for where the printer is in the G code while it's being printed.
Gotcha.
Do we want to go into pings right now?
Let's talk about some other stuff, and then we can dive into pinging and ponging and calibration. I think people have questions about streaks, and so we'll dive into the timing of filament later on.
Sure.
Cool. Okay. And I heard another benefit of the new encoder as well is that it's about $20 cheaper than previous versions, which has helped be one of the major parts that's allowed us to drop the price of Palette 2 compared to Palette Plus. So obviously a huge benefit there too. Okay, awesome. I have a note here to ask Brendan about the unibody substructure. It's sort of like the skeleton of Palette, I understand. I'd love if you could chat more about that, Brendan.
Sure. So this the idea of a substructure kind of goes back to Palette Plus.
And what part is the substructure on this?
So on this one, we can see.
Oh, interesting.
We've already taken this one apart, but
Gotcha.
you can see there's all of the parts of the system basically fixture to this part. So the reason we call it the substructure is it is sort of in the middle of the top and bottom casing. And the reason why we did that kind of goes back to Palette Plus. We did a similar thing with Palette Plus and had a lot of success with it. But one of the major design choices that we made in designing Palette 2 was we really wanted it to be easy to maintain and allow our customers to sort of see the whole thing happening. And so we decided that we wanted to be able to look at everything from the top down. And in doing that, we decided we would sort of attach everything to the substructure as a singular part. So it is by far the most complex part in the system. It has all of the filament channels. It has inserts for all the bolts. It has different textures in different places for different requirements of the system. So the buffer is sort of smooth where everything else is textured. And it basically houses all of the different components within the system.
It's funny that you mentioned the substructure as one of the most important parts of the system, because normally when I use a Palette 2, I kind of don't even think about it. I think about all the other parts. There's obviously drives and the splice core and the cutter, but the substructure is kind of just like there. And yeah, no one really gives it much thought, which I think is a good thing, because that's, if you're not thinking about it, that means it's working.
Exactly.
Very interesting. Thank you for sharing that. We talked about molding. I have some notes here about inserts for threaded fasteners. Could we talk about how things fasten to it? Any special considerations in letting it be structurally stable enough to be that skeleton?
Sure, absolutely. So we spent a lot of time designing the plastic and making sure the thicknesses were proper. And there's a lot of difficult challenges that we as engineers go through. So Ali and I, racking our brains and pulling our hair out about all the different details of how inserts fixture into holes and how you're going to make sure the bolts don't strip and all of these challenges. But if everything is working properly, no one should notice those things. And so everything from how big the holes are that the inserts go into, so making sure that the magnets that go in the bottom fixture properly, and how deep the two sides need to be so that everything clamps together properly. But I think the biggest challenge in doing all of that is making sure that we still fit everything in such a small space. So we spent a lot of time adding and reducing and iterating on these different challenges, but I think we've done a pretty good job of making it quite simple.
Gotcha. Thanks for that. One of the things you mentioned there was screws stripping or bolt stripping. I know there might be some folks in the chat saying, "Hey, my bolts are stripping." I want to chat about that a little bit, because I want to talk about thumb screws specifically. I know that working closely with the customer success team, we've seen some customers whose thumb screws have stripped a little bit and they're not effective anymore. I just want to let you know, if that is the case, please do contact our support team. We are happy to send you a replacement. I want to talk a little bit about that process and designing thumb screws. My understanding is that we ordered a batch of pallets. We experimented with thumb screws, and I think one of our intents, or one of your guys' intents in designing this product, was to have it be designed for ease of maintenance. We obviously hope that nobody has issues with blockages or anything like that, but in the event that that does arise, you designed the product to be as easily accessible as possible. That's one of the big differences about this product compared to Palette or Palette Plus, is you need only a couple bolts to access whatever mechanism you want, whereas with Palette Plus it took 4 just to remove the top cover. So my understanding was we previously had longer thumb screws, and then we found that it took a lot of rotations and it was kind of irritating when we wanted to access things. So we shortened them. And then, because of some slight variances in manufacturing tolerances, for some folks that meant that perhaps one of their thumb screws could be slightly loose in their Palette 2, or maybe only one thread would grip and so it would lose grip. So I just wanted everyone to know that the way that we approach hardware at Mosaic, I'd like to think it is slightly different from how most others do. We consider hardware iterative. We make changes, we make small adjustments. So one of those changes is that future Palette 2s should ship with longer thumb screws. And again, if you are affected by that thumb screw issue, please do contact us. We'll send you replacements, and we apologize for the inconvenience there. So, okay. we've talked about a couple things. I want to dive right into the meat and potatoes of Palette, the what it really does at its core, which is splice filaments together. So I want to talk about our modular splicer. So Ali, if you could walk us through some of the details about how does Palette 2 join together filaments? How is that different from Palette and Palette Plus did it? And what are some of the design decisions that we had to make to get to the state of where splicing is today?
Yeah, for sure. So, as Bobby alluded, this is basically our splice core, and essentially going back to Palette and what the product does at its core is it joins two pieces of filament together. So, going back to the Palette 1 days, essentially we had an open splicer where you had a hot tool and you had two pieces of filament, they would join, and then the hot tool would close, heat them up, and then basically fuse them together.
So the hot element was literally like rubbing against the filament to sort
exactly,
of
yeah.
Okay.
So it was in direct contact with the plastic, and you had some challenges with that. One, alignment was challenging. With the hot tool, you had to align it correctly. And also over time, the plastic would build up on the hot tool.
I remember with Palette version 1, the hot tool was sort of like shaped like a C. You'd have this like metal part here. The filament would go here and it would kind of wrap around. And Ali, what you were saying about aligning the height, that was, if it was off a little bit, it would cause additional friction, which would make the filament sort of build up a little bit.
Right, exactly. So we spent a lot of time in production making sure that height is actually correct before it leaves the door. But essentially that was a very, it had to be super precise to work properly. And the other thing that I mentioned was the plastic would melt and eventually build up on a hot tool, which led to other problems. You had to clean it up after a while. And so essentially what we did, we meet the two pieces together, heat up, compress, and then you make a splice. And then fast forward a couple of months, we basically discovered a new way of splicing, which was instead of your hot tool being in direct contact with the plastic, we found a way that you could have a really low friction material tube where your two pieces would basically align in. And then instead of heating the material directly, you heat it through a medium of material. But that material had to be something that would not stick to plastic.
So what would the benefit of having a material between the filament and the hot element? What is the benefit of that?
So the benefit is that you don't need to worry about alignment that much because essentially the mechanical positioning of the filament is done by that entire material. And then the second thing is that you have no chance of buildup occurring. So we sort of tackled the two problems that Palette 1 had with that. And so essentially this material had to be something that's low friction because, as we found out, when you heat the plastic, you sort of lose control over it. So if there's a tiny bit of friction after you compress, it's sort of hard to move out of the splicer region to maintain the diameter that we want to maintain. So after some R&D, we basically found that Teflon is the best material for this function. And on top of Teflon, we have a layer of copper. So I can show you guys what this looks like now. And those of you who've had Palette and then upgraded to a Palette Plus know exactly what we're talking about. But essentially, this is that black piece right there is the copper. And around it, we now have a nichrome coil, whereas with Palette and Palette Plus, we had an actual mechanical arm with the hot tool that I mentioned that would open up. And that was your heat source. But now that nichrome coil, as tiny as it seems, is basically our entire heat source. So what we learned going from Palette 1 to Palette Plus was basically we perfected this tube splicing method, essentially, figuring the materials right, figuring the tolerancing out, figuring everything out that goes with it. But what we learned after Palette Plus is that the tube actually wears out over time because Teflon is a soft material, but it was the only material that works for our application. So with Palette 2, we basically decided to design the splicer in a way that it's designed for serviceability. So that's why you get the...
So we'll switch cameras here to show this.
You have this tab over here, and you can rotate it out and pull it to pull your filament out. And then that's a used tube, and these are sort of one-time use. So once you pull it out after 15,000 splices, you have to put a new one in. but we basically designed it so that it's super easy to remove and install. And this wasn't the case with Palette Plus because we were trying to fit the existing substructure, and it was hard to do this.
So I want to interject here. One of the things you mentioned was 15,000 splices, and I know that I think some folks have had to switch their tubes earlier than that. So I'd love to learn what are some of the things that might affect the frequency with which you need to replace your tube.
Sure, yeah. So that depends on a few things. It's basically how much stress you're putting your tube under. The main factor is as you're driving your filament through the tube, the bite marks that the gears create, that basically acts as a sort of sandpaper, basically sanding your tube down. So depending on the material that you're using, that could make it wear out faster or less. So we've done the 15,000 splice test with PLA, but if you go to something that's less harder like Ninja Flex or TPU, it would last much longer. And if you go to something like a wood fill, it would last less.
Something abrasive, yeah.
And the second type of stress that you can introduce to your tube is basically how much you heat up and how much you compress. If you overheat, the material gets to a temperature point where it's easier to damage it. We never reached above the rated temperature of Teflon, but it sort of gets easier to damage as you make the temperature higher. And also when you compress, that too is taking quite a bit of stress, which is part of the way we solved it is the tight fitment of the copper and the peak tubes that basically hold the whole thing together. But essentially, if you over compress, you potentially could make the tube have more stress. But this is the exact reason why we include 3 tubes per unit for P2 and 5 for P2P, and they're super easy to replace. And if you do run out of them, we'll always be more than happy to send you more.
Definitely. So if you're in the camp of folks who have had to swap your tubes in your splice core in fewer than 15,000 splices, please do reach out to us. We are happy to help out there, and we'll take care of you. So. Okay.
Yeah, the other thing I guess about the Splice core is we are using pogos now. So going back to Palette Plus, you had to, it's much easier to remove it now. You have only one thumb screw and then you can take it out, and there's no wire to disconnect because the pogos basically do the job for you. So those are basically ways that we made it more serviceable to change your tube and maintain your product.
Gotcha. Thank you, Ali. Note to the 4 of us, I have done a poor job of stopping and reading audience questions as we are at the relevant spot. So please, if I'm not stopping, remind me. I'm going to visit some of the questions that we have been sent. There was someone who asked if we can talk a little bit more about the belt that operates the cutter. Sure. Do we need more clarification on what they're asking, or is that enough to work with?
No, that makes sense.
Okay.
So it's a GT2 timing belt, which is like the standard of teeth that are used. It's a neoprene, which is a type of plastic, and it's braided with stainless steel wire. So it is very, very difficult to break. It will last for millions, if not tens of millions of cycles. It is extremely strong, and we've never had a single belt break in the history of using them.
Noted.
Do you want to show how it,
Sure.
maybe the sprocket underneath?
Sure.
Yeah, sure. So as Buddy said, there's a sprocket. So the other half, so there's this cutter motor here, and the timing belt attaches to the cutter gear, which is where all the magic happens. Does that make sense?
Absolutely does. If you have more questions and that did not satisfy you, please feel free to clarify and ask follow-up questions. To everyone else, if we have accidentally glossed over your question because I skipped forward too quickly, don't fret. We'll have Mosaic people. I think we have lots of Mosaic people in the chat right now answering questions, but we can always circle back to it afterward as well. So please hold on to those. Feel free to send them. We do have Mosaic people who are currently aggregating all the questions, and once we get through some other features that we wanted to show off, we'll definitely follow up with those. So, okay. So we chatted about the splicer. Ali, I'd love to hear more about, so previously with magnets, we mentioned designing for ease of access, designing for ease of maintenance. Can you talk a little bit more about what are some other decisions that we've made to make it easy to maintain?
Yeah, for sure. So for reference, we have 7 PCBs in the product. Some of them are the switches that are under mechanical stress, for example. So early on in the design process, we decided to keep all of these above the substructure. So
all of the PCBs that have any mechanical stress.
yeah, so we can show.
So what do you mean by that? Mm-hmm. What are the PCBs? So you mentioned 7 PCBs.
Right. So we have 7 types of PCBs, and for example, this one, your runout switch, your homing switch under that one, and then your honk switch or your buffer switch right there as well. So all of these have switches on them, which basically your filament runs against. And as any mechanical system, it's under mechanical stress, so there's a chance that it could break. So all of these are accessible from the top of the substructure, so you could remove them with basically the screwdriver that we provide. It's only 1 screw for all of them, and you can change them quite easily. And then the rest of the PCBs are basically tucked at the back. So that's the main PCB over here, and then right behind it is the screen PCB that you can't see.
Behind it, okay.
Right
so
behind
hidden,
it.
gotcha.
Yeah. And then also the encoder PCB that Bobby was talking about is right here as well. So these are put on the back because they don't need to be accessed, but the other ones do. And
so when you say 7 PCBs, I saw more than that. 7 unique PCBs.
right.
Okay.
Yes, 7 unique PCBs. And pretty much everything else that you have to do maintenance on is accessible from the top. So your entire filament path is actually open and visible. With Palette and Palette Plus, that wasn't the case. So you had hidden sections that if stuff broke in, you couldn't see. But now with this design, you basically can see exactly what's going on. It's a lot easier to troubleshoot and clear for filament. And there's stuff that we did for manufacturing, for example. We made the cables in a way that they're length correctly, for example, like a small thing that the customer doesn't care, but the assembly people that are making it do. So you can't basically wire them wrongly. Like this cable is shorter than it is for this one, so you can't plug them in the wrong way. And we basically did a lot of cable management and making sure things don't get plugged in the wrong way, they don't get assembled the wrong way. And yeah, the other thing is like the covers, the clear covers that we use. This was basically to mitigate the problem I just talked about. Your filament paths, you could access them quite easily. And yeah.
Noted. Thank you very much for that. I want to take a peek at the chat to see if we have any questions that are specifically related to the things we've already chatted about. I see a lot of really good questions here, but I don't think there are any that of things we've discussed already. So we'll move on to some other features. Okay, this is a fun one because there are some secrets about it. Well, there's one big secret in particular. It's about the LCD screen. I've seen very astute palette users make bold statements about what they believe about. Do you know where I'm leading? Do you know where?
No.
Okay, I'll provide a better cue to Bobby. Rather, it's about the type.
Sure.
Yeah. Okay. So there's some really cool features about the LCD screen. Bobby, could you tell us about some of the major differences between, I guess the screen, how we interact with it, some of the features that are built into the screen, and then we'll start with that. Yeah.
Yeah, sure. So we should maybe grab a power supply so we can show. Let's grab this. Sure. But pop this up a little bit so everyone can see it. But this is our lovely LCD screen here. It is a 4.3 inch resistive touchscreen, or 3.5 inch. 4.3. That's what I thought. That's what I thought. But it's a resistive touchscreen.
Don't quote me on it, I'm not sure.
Here.
We'll measure.
It's 4.3.
There we go. Let's turn it on so we can see. There we go. All right. So for those of you with a palette, you'll recognize this menu screen. But yeah, this is quite a step up from what Palette and Palette Plus had back in the beginning. With Palette Plus, we had pretty much the standard 4x20 character LCD screen that's used by lots and lots of 3D printers in the industry right now. It is it's being pushed to its limits by the industry. And when we set out to design Palette 2, a big thing was making it as user-friendly to use as possible. And that started really with the screen. So that's why we went to a full LCD screen. So I think that Brennan was alluding to the fact that this has a pretty snappy response rate. I don't know if we can get is that what you were?
Oh, what's up?
You're saying how
Yes,
some people
definitely.
think it looks and feels like a capacitive touchscreen, and that is something that we are really, really proud of. We started developing this using some open source hardware. Hopefully I'm allowed to say this, but some open source software that came from PrinterBot, actually. Their PrinterBot Simple Metal Pro, the white one, kind of the last printer that they really launched, it had a beautiful capacitive touchscreen on it, and they made the software for that open source. So that was really cool. We learned a lot from using that screen, and we transferred a lot of knowledge from that to our screen setup. We started working with the capacitive touchscreen. We started sourcing our own screens because we wanted to move up to one that was just a little bit bigger. And we, for one, we realized that capacitive touchscreens are really, really expensive. And we also found that resistive touchscreens had almost the exact same response. I think that surprised all of us because I was thinking back to like the really bad first cell phone that I had that had really dull colors. But yeah, what we missed out on was multi-touch, that sort of thing. We don't have any UI features that require pinch to zoom or like two-touch scroll. So the resistive screen has worked perfectly for us.
There's a cool question here that I think is very relevant. It's from Afro 3D Printer. He asks, can we please talk about UI and design philosophy? Yeah, would love to.
Sure. As much as I've done a lot of the programming for this, for our UI, I am not the one that did any of the design work. That's all been handled by Derek, our CTO.
I think he's floating around in our
He's
office.
floating.
So maybe near the end of this, we'll be able to grab him and see if he can answer some questions as well.
I'm certain that he's listening right now, but that's okay. I can speak to it. The idea was to get people. Oh no, I just turned off. The idea was to get people up and running as fast as possible. So that was, really bringing. What do people want to do with Palette? Main thing is run a print. That's why our Start Print button is so big. That gets you into your SD menu as soon as possible. Next up was controls. We know from Palette Plus and Palette earlier on, and even 3D printers have jog controls. It's really, really useful to have direct control over each motor or to spin the cutter if you need to, go through all these sorts of things. So that was also put really close, really obvious to the user. From the controls menu, for example, you can clear the output. That basically gets all the filament out of Palette. It clears all the inputs and clears the output as well. If we go back, try and get some shadow. Yeah, oh, beautiful. Next up, this is one of my favorite parts of Palette 2, and we've seen some great prints come out of this on our Facebook group, but these settings in here are kind of the extra modes that Palette allows users to do. So things like multi-spool mode, that's very popular. Pattern, random, and gradient mode. So gradient mode, for example, we have this nice explanatory message, but it'll start with two colors, and approximately if you put in, do we have one?
We have
perfect.
one right over here.
Oh, the big one.
We have a big one, and we also have this one here. And this one is actually, if we can switch cameras here, I want to show this off.
Squishy.
This is a gradient mode, but it's something special. It's also TPU. It's a little bit hairy, but it's a squishy gradient vase.
So gradient mode, for those of you that don't know, does something like this. So if you know approximately how much filament is going to be used in this print, your slicer or canvas is going to tell you that. You can input that on Palette 2's screen, and you can select how large you want your segments to be. And that's going to give you, Palette will automatically generate the splices needed to create this really cool effect where you, at the bottom, start at a lot of blue and transition up to a lot of yellow here. We get just this really nice piece. It looks great for vases if anyone's printing a vase or some sort of bowl. Looks really cool. But the idea there was bring as much functionality to the user through the screen, just so that they can get up and running as fast as possible.
Gotcha.
Yeah.
Thank you,
Hopefully
Bobby.
that-
I have more questions for you, Bobby.
Perfect.
I have a question about what. So we have this big region here. It's called a buffer. I can see that there's a limit switch in there. We've also alluded in this stream to pings and pongs. So I'd love if you could share more about the buffer, about pong switches, what the purpose of them is, and maybe we can talk about differences between pongs and pings here as well.
Sure.
Okay.
Let me just get this open so we can look at what the buffer really is.
Okay.
Okay. So yeah, the switch, just so everyone is aware, what the switch that Brendan was alluding to is this switch right here. And this switch is supposed to get hit as the buffer closes. The buffer only closes, or sorry, a little bit of filament. Yes, so interactive. Let's fill this up.
So, yeah. So the okay.
So during a print, palette will make your palette is going to fill up the buffer to sort of this area. As the printer is pulling it out like this, the buffer starts to deplete. Based on, as I was saying earlier, based on the movement in the scroll wheel, we can see, oh, we've lost a little bit of buffer, and palette will make a little bit more. A technical detail in all of this that makes this more complicated is that when palette pushes more filament out like this, it's pushing in either a distance in millimeters or really a number of steps at the stepper motor. But when the printer is pulling filament, it's pulling that again in what the printer thinks is millimeters, but we really read that as counts through the encoder based on the movement of the magnet. So we have two different units of measurement here, and we have to calibrate those in some way, because again, over hundreds of meters throughout a print, if anything is off even by 1%, that adds up very quickly, and then you can lead to, especially in a constrained buffer like this, either something like this happening where there is no more room for the filament to expand, or like this where the buffer is completely collapsed and no one can, your printer can't pull any more filament out. So what we do throughout the print is this self-calibration. And we call this a pong, not to be confused with a ping, which we'll touch on a little bit later. But that's where palette will just stop making filament and wait for the printer to completely pull the filament until the filament hits this switch. If we can, no, it won't turn. So when this switch is activated, palette reads that, notices it right away, and starts to push filament out. So that works.
So that is the intent.
That is the intent. This happens approximately once or twice a meter, or once every couple meters, depending on whether or not there's a splice nearby. We do some planning around that because we are depleting the buffer here.
So it is intentionally designed that if palette is instructing itself to pong, it will only do that right after a splice and not right before one, so that you're not going to get completely stuck.
Yes,
provided that palette is making filament quick enough for the printer.
Yes, this is something that we even had to do with Palette Plus. Palette Plus had the same mechanism in its exposed buffer, and we had a magnet on the outgoing tube that would hit coming close to Palette Plus's front face, and there was actually a Hall sensor right behind the front face of Palette that would pick up that magnet, and the same thing would happen. The same idea is depleting this buffer, hitting the switch, and then Palette producing a bunch more filament. So one issue that I know that customers have been having, and we've tried to address this, is that maybe you want to, I don't know if I can force it to do it on this one, but what we've been seeing is that the filament might jam right here. Something like that will happen where the switch is now compressed. The switch kind of compresses like that, and it just physically cannot move. And this is bad because Palette doesn't know that it hasn't hit the switch. It's waiting for it to completely trigger like that. But the printer is still pulling, and this ends up in a failed print typically.
I think we've seen this in particular when printers are using particularly high retractions. I think sometimes that sends the filament sort of backward a little bit, and in some cases that has been enough to jam it. So how are we addressing that?
Yeah, we also see it a lot with the really tough filament. If there are already grooves in the filament that kind of make it like sandpaper, it's going to get stuck a bit easier. So what we do, we address this, and we've seen really good results with this fix. In one of our earliest updates was when we get close to the switch, when palette knows it's depleted to some level, we start to move the filament ever so slightly. I don't think I can really do it.
It's never actually fully stopped.
It never fully stops. So that as we come into contact with the switch here, the filament's actually moving a little bit to help bias the switch one way.
Gotcha.
Yeah. So just a note to customers, if you are upgraded to the latest firmware and you're still seeing this happen, please let us know. We can try to help you out a little bit further.
Gotcha.
Yeah, so that's ponging, the internal self-calibration. Do we want to talk about the difference? Unless we have any questions directly about that.
Yeah, we have a comment from JT that says clever.
Thank you.
I think those are I think we're okay. We can circle back if we do have some, but
yeah.
Let's talk about, let's go on to our next thing. Yeah. We spent a bit of time on the Pong switches, so let's keep it fresh. I think those are most of the specific questions that I had about specific features of the palette. But I think I think folks would be interested in just hearing more about the journey, hearing about maybe high-level design philosophies of what changed from palette to palette plus to palette 2. Do you have any battle stories to tell us from being in the trenches?
Lots of battle stories. Yeah, I'd say at a high level, one of the biggest things that we did focus on was this ease of maintenance, ease of use. One of the biggest comments we got from Palette and Palette Plus was that if things go wrong, it's very difficult to work with. So we really, from the very early days of designing the system, wanted to lay it out in this sort of 2D plane environment and have all of be able to view everything from the top. I think that was a really good constraint for us, and it put a lot of challenges on us designing around that. But I think it made the whole system so much easier to use and to test. I think that was a really fundamental choice that we made early on.
Gotcha. Thank you.
On the manufacturing side, we can talk a little. Where with Palette 1, we started manufacturing. There were a lot of off-the-shelf parts, like the PCBs, for example, we were getting off the shelf, and that had some limitations on what we could and we could not do. With Palette 2, we basically put in the time and effort to actually develop those from scratch. Every PCB is custom, and same with the actual mechanical parts. Like we were using sheet metal, and now we're using like injection molding, which was a huge sort of upgrade for us. And dealing with injection molding and sort of manufacturing in China has been really excellent for us.
Can we talk about injection molding for a bit? I know that I remember there was in early versions of Palette 2, there was at one point a metal casing, and then all of a sudden there was a shift and we went toward injection molding. Can we talk about why that was? And
yeah, do we have a Palette?
Actually, we have. Interesting. So we have here one of the
metal prototypes that we had. So this was designed with a sheet metal top and bottom, and some other fun features. So this is a really old version, but you can see some likeness to the existing Palette 2 and the final solutions that we came up with. But this is one of the first prototypes that we built.
The Splice core I can see is exactly like Palette Plus's.
Yeah, it was literally the one off of Palette Plus, just to save time in R&D. But we did a lot of testing with this, and I think early on we needed to design a system just to get up and running and question some of our fundamental assumptions in designing the system. But as we developed and got better at designing products and becoming more confident in the different systems that we were going to use, we knew that eventually we had to make a switch to something that was a little bit more scalable. And so part of that decision was moving to injection molded plastics, which are, there's a much higher upfront cost, but the benefits over the long run are very, very large.
Gotcha. I see we have a Palette Plus here or is this Palette or Palette Plus?
This is actually an original palette.
Oh, this is a Palette 1.0. Okay.
So this is one of the dinosaur units we have in the office.
So we can see here the splicer there's a channel that's exposed there where the filament goes through. That's where the hot tool.
And it would close like that.
Gotcha.
Exactly, yeah. So we got rid of one motor and a bunch of expensive components, and now we basically use this little component. So
Yeah.
you can barely see, but there's a nichrome coil on there, which is basically the same sort of coil that sort of vape products use. But we had to develop a clever way of making sure that coil doesn't short. Because it's sitting on a copper tube, and the coil itself is actually coated in a non-conductive material, so is the copper. But essentially, going from this product to that, we had to do a lot of sort of from the ground up supply chain work and from the ground up design work and injection molding. Like we have 10 molds, we have 2 injection mold suppliers that are basically handling the load of the molding. And one thing I wanted to talk about, which is
let's talk about drives.
Let's talk
because
about drives.
it's funny. Palette does, as we mentioned, Palette has 2 jobs. One, it has to make filament with precise tolerances so it feeds through printers effectively. 2 is it has to make sure that the right filament shows up at the right time. And part of that is making sure that it makes filament with the exact right length, that it drives filament together very precisely.
Right.
So I'd love to...
Exactly. So when you actually splice, the 2 ends meet and you heat and then you compress, right? So in order for that to happen precisely, you got to be able to drive precisely, because when your filament is molten, sort of every little imprecise drive movement sort of affects your final quality. So this is like the OG palette. We were using acrylic drives, as you can see right here, and we sort of had a constant design, constant distance design, where your filament would pass between a bearing and a gear. You can see in there. But the spacing between your bearing and the gear were basically constant. So what we found with this is our gears were off the shelf, our bearings were off the shelf, and we found that eventually when you drive, each drive would vary compared to one another. And because of the reason I mentioned, you need the precision, that wasn't good for us. So we went back to the drawing board and we basically made the same drive system out of aluminum. And we also found a way that you could, using a screw, sort of bend an arm in the aluminum to make sure you could tune it right. And we invested in a pretty expensive drive tuning rig where you measure the exact torque that it requires to drive each drive, and you tune it in a level that every single drive going through that torque tuning rig is within the same standard. So that's how we solved the problem. The other big part that we had to solve as well is we actually manufacture our own gears. The gears that we got off the shelf, the tolerances were pretty terrible. And we found a supplier that manufactures their gears to a very high tolerance. So that got rid of a bunch of the variance between the drives as well. But essentially what Palette 2 does now is, instead of constant distance, we're using constant force. So no drive tuning anymore. So it's a lot more reliable with different materials, because with constant distance, if you're driving a rigid material versus like a flexible material, the difference between the two could add up.
So we've thrown a few terms around here. We've mentioned constant distance and constant force. And so can we talk? My understanding of constant force is that you have a drive gear. Let's use my fingers as the drive gear. You have a bearing, and the distance that you control is the space between them, so you can say how much does the gear bite into the filament, which changes the amount that it is driven. How is that different? What does Palette 2 use now, if not constant distance?
Yeah, so if you switch to this other camera, we can show on Palette 2 now. So you see we have a spring over here, and we have the same gear and the same bearing as well. And in this case, the spacing between the two is actually determined by the force on the spring. So when you put your filament in here, it spaces it out just enough. And we basically did testing to figure out what force we need on the spring to make this work for rigid and flexible material. And essentially, it gets rid of the variance between the two because the distance is variable due to the spring compressing. So another thing that we did for pallet 2 that pallet plus and pallet 1 didn't have is the gears on pallet 2 are actually pressed onto the motor shaft. And
as opposed to what?
As opposed to with pallet 1, we had a set screw the same way that 90% of 3D printers are as well. Everyone uses a set screw because it's easy. You buy the motors off the shelf, you buy the gears off the shelf, you screw them together. But with us, we wanted to make sure that there's no way that the gear could slip and come off the drive. As we saw with the set screw design, it gets loose over time. And to avoid that with pallet 1 and pallet plus, we were adding Loctite on the shaft to make sure that it fully cures to the shaft so that there's no way of it coming off. But that was messy and time consuming. So with pallet 2, we basically dealt with the supplier to get the gears to them and make sure that the tolerances on the shafts are right so that they're pressed on. So there's no way those are ever coming loose. And it makes the final assembly a lot easier as well.
Gotcha. Thank you, Ali. I see Marshall, who's running audiovisual for us. He is holding what I think is the first pallet, the first prototype of pallet. Oh my goodness, this thing is enormous.
Yes.
All right. So we're gonna swap to our other camera here.
You can see it
Holy
says
moly.
Demo unit only.
So this is the scroll wheel that we were talking about. It was sitting outside the box, same with pallet 1, pallet plus. And it sort of was another thing you had to deal with mounting it on your printer.
Wow.
We've come a long way, as you can see.
What is going on in here? Here drives.
Yeah, 3D printed drives, optical encoders, splicing system.
I see some heat sinks here.
Yeah, this big red arm is what we call the guillotine. It's got the blade on it.
Oh, so this is the cutter that drops straight down and would have the huge thump.
Yeah.
Interesting. And what's this over here? Is this also an encoder?
Yeah, outgoing drive, I think.
Yeah. Interesting.
And then
the tube at the back.
Yeah.
Gotcha.
So you can see from a systems level, the system has not changed all that much. We've just gotten a lot more refined in the way that we execute, which is exciting.
Very cool.
Yeah, I think one of the big things that Ali was alluding to is this design for manufacturing, and I think that's something we've gotten a whole lot better at Mosaic. And when we sat down to design pallet 2, we talked a lot about designing in a way that we could scale manufacturing. And so we moved away from things like custom components that were machined or made in processes that weren't scalable, and moved towards things like injection molding. Or mass manufactured techniques that we use now. Gotcha. So things like pressing the gears on that Ali mentioned.
Gotcha.
And so part of that was actually making the design so that it's mass manufacturable, like injection molding versus sheet metal that we had with pallet 1. And the other part was actually finding the right partner for manufacturing. So we spent quite a bit of time finding the contract manufacturer in China that is up to our standard for manufacturing.
I remember you guys spent a lot of time traveling and interviewing different potential partners.
Yeah, Brennan and I spent quite a time.
Yeah.
We have some really cool comments from the chat here. Sue 3D Design says, wow, with multiple exclamation marks. KC says, how many gigawatts does that beast use up? Skooma Video says, amazing. All right, awesome. I'd love to chat about high-level philosophies on development. How did things change? You mentioned you use a lot of off-the-shelf parts. How did things change from the perspective of the development process and how you thought about it?
Sure. I think when we started with pallet 2 and even going back to pallet plus, I would describe our design philosophy as much more of a systems level iterative approach, where we would try and design the whole system and just iterate through trial and error to make things better. And that was really helpful for getting things off the ground. And testing some of these very large systems level assumptions, like can we make the whole thing in a 2D plane? Is it easy to see things from the top? But quickly we discovered that there's a lot of very difficult nuance to each subsystem, and I think we've moved more to a test-driven subsystem approach, where we do our best to make sure that every single component and subsystem of the whole system is working as well as it possibly could.
What do you mean by subsystem? What are Palette 2 subsystems, and how do we divide them in our minds?
Sure. So I would break them into drives, cutting, splicing, calibration. So that includes the buffer, pinging and ponging that Bobby was talking about.
So you mentioned drives, and
Drives, cutting, splicing, and then all of the calibration mechanisms.
so the buffer, ponging, pinging, scroll wheel. Okay.
Yeah, and I think as we've gotten a lot better at building the system as a whole, we spent a lot of time tuning each one of these things individually. So one of the biggest challenges we had in developing this was it's very difficult for Bobby and the firmware team to develop on a system that isn't finalized yet. So the hardware team has to build a system that they can do testing on. And as they do development, we might be changing things as the hardware team. And so there's this iterative approach. But the further we've gotten with this process and the better we've gotten working together, we found that more often than not, you can test each subsystem individually and then work to sort of bring them together as a whole. And now that we're working in sort of the last tail of making each of these systems the best that it possibly can, that approach has been a lot more fruitful, a lot better at making all of these things work.
Thank you. Okay, I think we have, that's the bulk of the main things that I wanted to share and show off. I think we have quite a few questions here. So someone on our customer success team has been aggregating these and sending them to us. Thank you very much, Addie. Let's see. We have a question. So some of these questions, I want to preface this by saying we may not be able to answer. And I think this might be one of those. We have a question from Marmau78 saying, congratulations for the fantastic product. I would like to know if there are any plans to add in future multiple filaments mixing color in palette. That's a big question, and color mixing is interesting, but I don't think that's something I don't think we believe that is where we can add the most value in 3D printing, but who knows what the future holds. We have the question about belts from the Happy Extruder, which we've answered already. We have a question from Dominic Chen saying, any plan to support more than 4 filaments with the existing Palette 2? Maybe a software upgrade can do it.
I don't think so.
I think it depends on what we mean by 4 filaments as well.
Physically, and we joke about this internally quite a bit. Physically, the firmware team can only really do so much in the physical world. So
what does that mean?
No, just so if you want to get more than 4 filaments at a single time, you might have to hold your breath, wait for a little bit longer, maybe a future product way down the road. But if you're talking about throughout a print, Palette Plus had a really cool feature that we called hot swapping. It is on our roadmap for the next 1 to 2 releases. Look out for it. So the firmware updates coming early this year should have this hot swapping feature. What hot swapping allows you to do is when you finish using OneDrive, you know that, let's say, do we have a good one? Let's say in this multicolor part, if you know for some reason you want to switch out your red halfway through the part, you can say, I want this to be blue now. Using the palette screen, we're going to allow you to swap that out. Say, I'm going to switch drive 1. It's going to unload your first drive, and then it's going to ask you to reload with your new filament. So if that's what we're talking about, then for sure that's coming in the next 1 to 2 releases.
Gotcha. That it'll be nice to have more a proper implementation of hot swapping. A pro tip for those of you who want to use more than 4 colors right now, when palette is using one filament, the other drives are disengaged, the ingoing drives. So if you want to, you can swap out a filament that is not being used simply by pulling it out and then replacing it with another filament, making sure that the replacement filament is correctly gripped by the drive gears. So you do have to force it through there with a little bit of force because, and the reason why that works and why you don't have to be too precise about how far you push the new filament is because before every splice, Palette's homing switch will detect the location of the drive. So you can, that feature is available now, but not in a way that is sophisticated as of yet.
Yeah.
So coming soon.
It's coming soon, we promise.
Noted. Okay. Dominic Chen says, any test data for splice cores, pro or non-pro, before it fails? I have a pro, but just a bit concerned about the lifespan of my unit.
Yeah, so the difference between the Splice Core Pro and the regular Splice Core is in the tubing. So we spend more time on the Pro figuring out the tubing diameters and thicknesses that would make it heat and cool faster. They're essentially, they operate in the same way. So in terms of lifespan, they both are tested to the same level. So technically, the only difference between the two is that the Pro heats and cools faster. So you could splice slightly faster compared to the regular one. In terms of lifespan, you can expect the same. So I wouldn't be too concerned with that.
Yeah, I think, I mean, how many... We had a stress test going where we had a unit that was just heating and cooling for I don't know how many.
It still is.
It still is.
Still going.
So we started in 2018. It's 2019 now. It's been on for I believe 85 days or so, and it's done
just on and off constantly.
Exactly. Yeah. So we're doing that test to basically stress the system. So we're stressing the nichrome, we're stressing the copper, the contact between them, the shorting issue that I was talking about, and then it also stresses the tubes because the Teflon, as it heats and cools, it sort of expands and contracts back down. So that adds some stress. And up to the 15,000 or 3 kilometer filament distance, both the Pro and the regular are basically fine for that. Yeah, so I wouldn't be worried about that at all.
And of course, if you do run into any issues, please reach out. To my knowledge, I don't think Mosaic has seen any units where the splice core would just stop working. We certainly have seen folks who have needed to replace their tubes. But knocking on wood here. But please, if you see any issues, do reach out to us. We have a great support team and we'll take care of you.
Yeah, and every unit before it leaves the factory, it goes through an extensive QC process where we do a number of splices on every single unit. So I know some people were mentioning that the buffer surface, because it's so nice and shiny, some of them, they mentioned there might be scratch. So that's the reason, is because every single unit is basically being tested for its final performance. So that's why you see that. But
and that's totally natural. It's kind of hypnotic, the pattern it produces in the unit.
Yeah, exactly. And the splice core is basically the main thing that's being tested in that test as well.
Gotcha. So if you have slight scratches in your buffer, it's not that you're getting a used unit, it's that there was quality control testing. Okay. Noted. Okay. We have a question from Afro 3D Printer saying, how many iterations did it take to get to where we are now, product-wise?
Well, I have about 3 shipping boxes next to my desk full of prototypes, so approximately that many.
One of the benefits of being a 3D printing company is that we have a lot of 3D printers that we can use in prototyping. So we've seen firsthand how it can help in the design process. But yeah, we have, Brendan, I know you have, by your desk, you have all these boxes of like different substructures and cases. And
my estimate is probably close to 50. Some of the iterations that we make are very small, so we're just tweaking dimensions here or there. There's slight tweaks that we made even just before going to production on some of the molded parts, but if you trace it all the way back, it's close to 50.
Yeah, so the iterations are interesting because some of them are on the R&D and design level, where we basically order a few like machine parts of each component and we basically test it out. But we also do, once we go to production at scale, we do testing before we start the production line. So we did a pilot run production, and that's where we found some of the problems that show up at scale, but don't necessarily show up when you're testing sort of 10 units, 20 units at a time. And that's basically, after that pilot run, we had some iterations and we had to change some things to make sure that they're up to spec. So there's 2 levels, 2 iterations.
Gotcha.
One is less costly. One is
one is design and one is at scale. Are all of the tolerances correct, and is everything working?
Yeah, the second one is when your blood pressure goes up.
One is yelling from desk to desk, and the other is yelling over the phone while we're continents away from one another. So.
I think also on iterating, we were lucky designing Palette 2 that we had Palette Plus in the marketplace already, because they are very similar systems, and we were able to leverage one in order to test the other. So we had this nichrome concept, this little wire that you can barely see.
It's super tiny here. It's like
we had to prototype this so many times, winding them by hand. But that started out, we tested the idea of heating and cooling like this in a pallet, which I think we still have that one. And it worked, which was really cool.
Yeah.
So definitely having a few extra things around the office never hurts. It helps us move faster.
awesome. Chris, one of our co-founders, is holding pizza outside the room now, asking if we're hungry. It is a Friday night. It is around dinner time here in Toronto, so don't mind us.
I wonder what it is.
Let's see.
Can we get one of those gold effects?
We have a question from the Happy Extruder saying, question, so when is the back-to-back Palette 2 8 splicer version being launched?
Yeah.
not sure if we can disclose that. Yeah.
Surprise. Tomorrow. No.
3DP Iceland says, will FlexFill 92A work on the P2?
92A is a shore hardness.
Yeah.
I would say yes.
So there are a broad range of flexible filaments, ranging from Ninja Flex, which I think is like 95A,
It
which
might
is
be
probably
lower than that. It's probably about a 90A is the lowest that I've seen.
I think someone's fact checking for us right now, so we'll get back to that. But
right.
Ninja Flex is, I think, the most extreme as far as flexibles go. And then at the other end, we have other filaments that are still flexible, like this one. I don't think this is Ninja Flex, but it might be like, yeah, it's a TPU. And we have lots of brands of TPU.
It's 85A.
85A for Ninja Flex. Okay.
Thank you, Marshall.
Gotcha. And we have, so certain TPUs will work very reliably. We've been doing a lot more TPU testing in our office. We have lots of in-calibration, multicolor TPU prints. So we know that TPU can work very reliably. It does require some calibration changes and a different printer profile. And we're happy to answer more questions about that as well. But I think it's sort of like a continuum. I think there is a chance, as with printing, that a very flexible filament can cause a jam. Palette 2 is very good with flexibles, but not completely flawless. If you use it enough times, even the most reliable machine will fail. So with Ninja Flex, the frequency of jams will certainly be higher, but we have certainly done a good handful of splices with Ninja Flex. And we're at a point where I would consider TPU splicing, once calibrated, very reliable right now. So if you're running into issues with TPU, do reach out and we can help you with some good default settings there. So
For sure.
Let's see. We have a question from Christopher Hogue, I hope I'm pronouncing that correctly, saying, given 2 nozzle systems and E3D tool changing heads, how do you see Palette integrating into color or multi-material printing in the next 2 years? Will we see your devices driving multiple nozzles and tool heads?
That's a great question.
That is a very good question.
Yeah, I think we can speak to that for sure. Especially we've seen in the last year or two that the IDEX systems are becoming a lot more popular. They improve on a typical dual head nozzle where you don't have one right over your part as it's oozing. we don't necessarily see them as an alternative or a competitor to palette necessarily. We see them as another way to upgrade your printer. So something like even the E3D tool changer, the nice thing about having multiple nozzles is that you can have them at different print settings. You can have a really large one, a really small one that's running at 240 printing PETG, and one at 210 printing PLA. So we definitely do see a future at some point. I'm not going to say when or for sure, but definitely having some sort of system that allows us to take advantage of tool changing systems or IDEX or duals for sure.
Thank you, Bobby. We have a question from Dominic Chen again. Thank you. It says, what's the purpose for other ports on Palette 2? There is a round one. Maybe the time to chain up two machines. LOL with several smiley face emojis.
Yeah. So that was my doing 100%.
You are responsible for the round port.
I'm responsible for it. It's not being used right now. I apologize. No, we call it the auxiliary port. Palette, we never talked about Canvas Hub, but this is a Canvas Hub for those of you that don't know. It's a little white box with USB ports on the side. It has a Raspberry Pi, and then it connects to Palette over its USB port. Palette and the Canvas Hub talk over serial. What we thought might be cool in some future. Also, we plan to integrate Palette 2s into printers at some point in the future. We want to expose a more hardware-friendly way of getting at the internals of Palette. So that auxiliary port, it's not actually used right now, so don't go jamming wires in there. But it can be hooked up to a serial line on one of our microcontrollers, and that could expose some of our communication. Either the plan was hoping to expose it to printers that we may be integrating with, or possibly accessories to an accessory product, whatever that might be.
Thank you, Bobby. Okay, let's see. Those are the questions that were aggregated for us. We're going to jump into chat here. If you have more questions, please do let us know. Yes, that's a great suggestion. So Marshall, who's running our AV, suggested we mention talk a little bit about Canvas Hub, how you can make your own. Bobby mentioned that Canvas Hub has a Raspberry Pi inside it. Canvas Hub's source code is open source. You can make your own. So please feel free. I think the intent of Canvas Hub, it was to, we believe that using Canvas Hub can provide a better experience. It's not necessary. There are certainly printers that are reliable enough so that you don't need it. It adds the benefits of having Octoprint, but certainly the goal of Canvas Hub was to make a connected experience as accessible as possible. If you're the kind of person who has Raspberry Pis around at home that you tinker with and are a master with, please do feel free to make your own. One of the things we're working on is our 3D modeler, Ajay, he's awesome, and he's working on cases, custom Mosaic branded cases for Raspberry Pis. We'll release those files online, so even if you build your own, you can have a Mosaic official Canvas Hub, even if it's homemade. So we're working on that as well. We had a question there about a Canvas Hub supporting a USB camera as well. So with Canvas Hub, we haven't done a lot of experimentation with cameras, but we do. The intent with Canvas Hub was to make it as accessible as possible. So it is not the most powerful Raspberry Pi. Perhaps those who have experimented with cameras in Canvas Hub can comment on whether that was successful. But if one of your primary needs is using a camera with it, certainly do consider building your own with a more powerful Pi. Because the goal again with Canvas Hub was just making it accessible. Let's see, we have several more questions here. Imagination to Form is asking, what is the answer to life and everything?
Definitely 42.
42, yeah. Obviously.
Unanimous vote for 42. Okay, let's see. Let us see. To our customer success team who's watching alongside us, I would certainly appreciate if you could help us send some more questions here, so we can so that we can minimize this time. But I think we've gotten through a lot of them. If you have any more pressing questions that we haven't answered yet, please definitely do jump in. We have a little chuckle from Imagination 2 Form here. The Happy Extruder is asking, can we show the hub inside the case and its components?
I was
Can
trying
you
to
also show off the snap?
Oh, okay.
snap.
We'll do the snap right now.
Okay.
Ali
This
spent
is-
a lot of time on this.
So this is it. You can take it off.
Here, let's see. Let's take a look at the inside. Give us a tour, Bobby.
Sure. I'm gonna kind of pop it up. So the idea behind, thank you. Okay. The
Trying to
idea
get in
behind
focus here.
palette or canvas hub, the thing that we're talking about, was to make it very easy to assemble. So this is everything, and then you have this top and bottom lid that just sit together nicely. Ali designed this in like what, a day, a couple days.
Just
and then
the snapping
and then
mechanism here.
Talk
yeah.
about iterations. I think there were 2 or something. So this was made really quickly, which is a testament to Ali's design skills. It looks really cool. You've got this nice clean Mosaic logo on top, and then the snap that we were talking about.
You have to rotate it.
Oh, okay, thanks, Ali.
So there you go.
I got it. All right. So the nice thing is that you can take this off without any tools. It's held in place by these injection molded clips, and when you put it together, it sounds so
yeah.
nice.
That sounds
I
fun.
hope that really came through the audio.
What do we have on the PCBs here?
So here, this is basically a custom USB hub, and it also provides power. So that's a typical Raspberry Pi W.
What is this here? This 100%.
Yeah, 100% gluten-free. So I wouldn't suggest ingesting this, but if you do,
It is gluten-free.
It's
It is
gluten-free. So
True advertising.
we do not advocate that you ingest any of these things. So yeah, here, just a little tour of what's going on. You've got your power input there. We have this light.
Let's try and hold it level here.
Sure. That light, although it's really important to see the light, right here, it shines really brightly, and you'll see that it comes through right about where my finger is, and there's no hole there. It just shines through the white plastic. Looks very sleek. Another design decision by Ali. And then these 4 USB ports here, they just expose the USB functionality of this little chip there. And then one thing that we're a little frustrated by, and our lead electronics developer, who may or may not still be here, Bruno, he got tasked with connecting these 2 boards together, which is not an easy thing because the Raspberry Pi Zeros, they don't have many standard mounting points. They have a micro USB that they use for power, and then this is a USB on the go port, which we then have to break out, flipping over again, and that gets routed to the USB hub there. So we actually got surface mount male micro USB ports and had to position them properly so that they would interface with the Raspberry Pi Zero properly. And then this is a SD card that has our it's basically an Octoprint image. It's running regular Raspbian with Octoprint on it, and then all of our custom plugins already flashed onto it. Yeah.
Awesome. Thank you for the tour, Bobby. Show the no gluten from Christopher. There we go. We also have a couple other Easter eggs on palette. Hint, check out the PCBs. Okay. We have a question from Thomas Mraz asking, are the side purgers and buckets much more efficient than the typical blocks? And what are the benefits of them? Mm-hmm. Any thoughts?
Yeah, so that's referring to, I think, a couple features that can be enabled in Chroma that talk about side transitioning.
Yeah, Chroma or Canvas. Mm-hmm.
Right. Canvas has a note too. So side transitioning in a part, again, we don't have really an example of a part that would take advantage of this, but if you have a part kind of like our cell model, unless we have one here. No, okay, I'll just run with it. If you have a part that has very long stretches of the same color, if you're building a transition tower next to your part, like what we usually do, you have to build basically just support structure all the way up so that the next time you transition material on the tower, it has somewhere to print on top of. If you enable side transitioning, you can move to the side of your bed, and as long as when it extrudes, it doesn't go down onto your print bed. Oh, perfect. We've got something coming in. Is that gonna? That's infill transitioning. All right. Anyways, I'll show those later.
Maybe the Hulk behind you is a good example.
Yeah, so I guess there are a couple of things we're talking about here. When we talk about the benefits of side transitions, there are several. One is filament saving, which Bobby was alluding to. If you have a part that is the same color for a certain stretch in the Z dimension, or Z dimension for fellow Canadians out there, then there is no need, you don't use any filament building up the tower, and all filament in the tower, or rather for purging, if you're using the side transitions, is purely for cleaning out the nozzle between colors. Whereas when using transition towers, even if there are no color changes, you use a little bit of filament. Its default is 5% infill, so just a slight amount of filament to build it up there. So I think you save a little bit of filament, you save time as well from being able to purge faster on the side versus having to print the tower. And you also regain bed space as well. We know that filament usage and filament waste and conserving filament is a priority for many folks using Palette 2. Brandon, who is our Canvas technical lead, he brought in some of these towers to show off here. So this here is demonstrating infill transitioning.
So yeah, this might look a little confusing as to like why would anyone want this, but if we look strictly at the sides, you can see that this side was supposed to be white, also white. This side is black, and this side is black. So this is what we affectionately call two triangles sitting next to each other. Classic test print at Mosaic. So what you can then see on the infill is that in order to get that nice perimeter, we still had to transition, but all of that transitioning happened on the infill of the part. So you can see in here, we did in fact transition there, and also we transitioned there. And then the same idea on this one, you have this gray triangle. It's a little bit tough to see on one side, and then a green triangle there. And then likewise, you have a bit of transition here, and then you can see the transition there. So this is also, if you're really concerned about filament usage, this is another really good way to save on it, because in a part like this, you can almost have no waste at all. The kind of gotcha there is that we upped the infill quite a bit on this one so that we'd have more infill to purge into. If that's something that you're already doing or okay with doing, then this is a great option. And then one more option that we can just kind of imagine with this one is typically when multiple colors or multiple models are sliced next to each other, we print one layer and then we print two more of the other and then two more of another, and it kind of like jumps up that way. This isn't actually the most efficient way to do that. With most nozzles, you can go up about 4 layers. It's higher on other really small nozzles. You can go up about 4 layers on one, and then on the next model, you can actually do 8. So that makes the amount of times that you have to transition in your part, cuts it down by a factor of 4, I think, if I know my math. So that's also going to save on your filament usage quite a bit. So if you combine all of those things, we had some numbers, but you can really drastically reduce your filament waste.
Definitely. When we talk about filament waste, that's certainly a priority for. I think there are a couple of different things that. A couple different aspects of Palette that we know that folks care about and that we are working on. I want to talk a little bit too about Canvas, because the folks who are in our chat right now and watching, probably many of you have owned Palette 2s, have been experimented with Canvas, have run into perhaps some technical issues, and I want to talk a little bit at a high level while we have you here. The intent of Canvas, the state of Canvas, where it's going. Canvas is currently still in beta, and there's a big label. And I think that I, on the business side of things at Mosaic and our business team, I think we can do a better job at helping communicate to customers because I know that some folks are not happy with the state of Canvas. And I think there are a couple things there. Some of them are stability, some of them are speed. And I think one of the mistakes that I think I made was when we launched Palette 2, we certainly wanted people to use Canvas because we do think in the long term that it will absolutely provide a better experience, way fewer steps, a lot of other powerful features that will make it really easy to share your prints, troubleshoot, and we've mentioned coloring a few times, and you can discover that more on our website. But the reality is Canvas is in beta. There is still a lot of work to do on that, and we know that, and we appreciate everyone's patience and feedback. But we do want everyone to know that Chroma is quite stable. Chroma is a great option if you are not happy with the state of Canvas. But if you are the kind of person who wants to be on the cutting edge and interacting with the company and giving them product feedback, we do encourage you to please try Canvas. If you run into an issue, definitely feel free to swap over to Chroma. Please send us any bug reports or logs you have, because we have an awesome Canvas team. They are incredibly dedicated and working on improving Canvas. I want to make sure that I don't share anything I'm not allowed to. That we're working on a lot of things related to making the UI better, making it easier to find your printer settings. We're working on stability. We're paying attention to speed. We're looking at all of the small requests that people make about wanting a certain feature that's available in another slicer. Those are all things that we're paying attention to. I hope that others in the chat would agree that we put a lot of effort into making sure that we're accessible. We try and be transparent about where our heads are at, what our highest priorities are, and improving Canvas and Canvas stability is definitely a big one for us. I am certain that several months from now, everyone will be thinking about Canvas in a very different way. We have a lot of neat things coming out. So that's all I'll say on that. But it's similar things happened with Canvas Hub. There were some stability issues. Hopefully, there were some issues about being able to connect from Canvas and sending files to Canvas Hub. We've pushed out an update for that. I believe that things are much more efficient with that workflow. So again, if you run into issues, do reach out to us. We work really hard to be accessible on any platform where you can find us. We have folks using their personal Reddit accounts, sending private DMs to chat with folks. So again, do reach out, and thank you for working with us on this. But again, there are options. You can use Chroma. I know that there are some folks in the community, Tim and Tom, who have been working on a slicer plugin to help process files for Palette as well. So there are a lot of options out there. You are not restricted to the cloud if you do not want to use it. That's all I'll have to say on that. So thank you. We have a question from Dominic Chen saying, can you talk a little bit about roadmaps for future features Mosaic is working on? Any comments? Obviously, we don't want to share too much. Sure. We want to surprise people a little bit as well, but any thoughts on features we can share, comments on?
Yeah, one thing I would say is we spent a lot of time looking at multi-material and making that a lot more stable. So flexibles is a challenge that has come up in the past. That's something that we've put a lot more time and effort into more recently. And I think just in general, multi-material is something that we think about all the time. It's constant. We're constantly doing multi-material testing here at Mosaic. And I think there's a lot of advancements that can be expected in the future in that arena.
And when you say multi-material, explicitly combining two materials that are not the same, as in PLA with something else? Or...
Exactly.
Noted. Okay. We have some questions in the chat about rogue lines or streaks in the model. And that's definitely something we want to chat about. We mentioned earlier in the stream that Palette has the two jobs, making filament with precise tolerances and making sure that the right filament shows up at the nozzle at the right time. And one of the challenges about making sure that the right filament arrives at the right time in the nozzle is that there are a lot of inputs that can affect that. For example, skipping from the extruder can affect that and sort of throw things off. If a printer uses less filament than Palette was expecting, well, then we'll have a little bit of extra filament, and that may appear on the part. So that's why we mentioned that it's very important to tune your printer and have it working very well in a single color before using Palette. That said, not all streaks are caused by skipping or issues on the printer side. Certainly, there can be challenges with pings as well. Pings are something we haven't touched on yet, and I think we can go into those, maybe not at too deep of a level, but high level, what pings are, the difference between them in accessory mode and connected mode, and why pings are essential. So pings are like mini checkpoints in the print. We mentioned that we have the scroll wheel, the rotary encoder that very precisely tracks the printer's filament consumption. But in addition to that, we also need to know where in the print is the printer when the printer has consumed a certain amount of filament. And using the combination of the amount of filament and how much filament we are supposed to have used at that point in the print, that is the data that we need for Palette 2 to adjust the filament segment amounts. So part of that is detecting these checkpoints or these pings. In connected mode, those happen automatically, digitally, communicating between the printer and the palette. But in accessory mode, so when you're not using a Canvas hub, we do that by inserting a series of unique commands into the G-code that palette can detect through the scroll wheel. So if you'll notice on the tower, if it's pausing, you'll see the print head pause on the tower. It'll extrude a little bit, then it'll pause again. That's a ping. And we call that series of movements a ping signature. There can be some challenges sometimes, depending on printer firmware as well, on whether or not palette can pick up that ping accurately. So if you notice, the pauses are supposed to be, I think they're 13 seconds and 7 seconds. If you notice your printer pauses only briefly, for example, we have a feature called movement pauses, where effectively we'll extrude a very small amount while moving, so it will look like a paused palette. So there are features like that where if your printer is having issues detecting pings, consider enabling movement pauses. That's available in Canvas and Chroma. But instead of worrying about that yourself, please reach out to our team and we'll help you through that, because we've seen all of the issues that can arise and we know how to solve the large majority of them. And if we don't know how, then we also have a very helpful community who can answer questions. And I see a lot of those helpful folks in our chat, like Skooma Video or Skooma Man on Facebook. So again, please reach out to us if you run into issues, because our support team is here to help. Let's go back to the rogue lines. Part of that is helping improve ping detection algorithms so that we can detect pings more effectively. And part of it, I've heard of an instance where someone said that palette was supposed to go to a certain color and then it skipped over that color entirely. We haven't seen a lot of issues, but we've heard enough from people that it's certainly worth investigating. So we're running prints constantly. We have probably 24 printers here, and we have most of them going most of the time. So we are running a lot of tests. We're paying attention. We run into streaks occasionally ourselves. So those are issues that are top of mind for us, and you can certainly expect those to improve. Mm-hmm.
Yeah, just because I know that this is really one of the major problems, especially in the community right now. This is top of mind for me especially, and there will be a few other people not brought onto the team, but sort of brought onto my team to make sure that we have enough resources to really tackle this head on. Because I, more than anyone, totally understand that when there's one line out of 10-hour print, 12-hour print, it really ruins it. And we in the office hate when that happens, and it's so much worse for you guys. So I promise that we're working on it. It is, number one thing right now.
Thank you very much. Any other questions? Let's see. Chris P1 says, after replacing the splice tube, do I need to reset a counter on that?
Currently, no.
Okay, gotcha. But the purpose of that in Palette 2's firmware is when you replace a tube, if you want to keep track of it, you reset it in there so that you know how many splices have been done on...
We don't... no, we will add that functionality.
Okay, yes. Gotcha. Thank you. JDC AMC asks, how much filament do y'all go through?
A lot. I think Marshall might be the best one to answer this, but
hundreds of kilos.
Yeah,
Too much.
Yeah. A tricky thing for us is that we both try to test and actually print things for content for ourselves, just things that really push the limits of palette. So sometimes there's a color that you really, really need, like a specific pink that you might want, and you might see this being used for an engineering test. That's really not a good sign. Yeah, we go through hundreds of kilograms of filament a year.
We sure do. We have a question from RM asking, when can we expect the firmware release where easy printing with TPU is added, as was promised on the support forum? So I think when, RM, thanks for the question. I think what you're referring to is, right now, if you want to print with TPU, to do that effectively, there are a couple things you need to do. You need to use a different printer profile in Canvas or Chroma, so that your pings are treated as separate from your normal printing. And you need to calibrate your SPC, or your steps per count. That's the value in pallet that controls how many times the drive gears rotate when it's trying to make a certain amount of filament. So question on, when can we expect easier printing with TPU?
Yeah, definitely. In relation to what Brendan mentioned in the future roadmaps, multi-material support, including, say, TPU to TPU and other materials with other materials. That is on definitely the next thing after hot swapping, which we talked about earlier. Definitely those are the two big things right now, is multi-material support and hot swapping. So look for it in the next 1 to 2 months.
Gotcha. Thank you. Okay. Any other questions? We've gone through quite a few. We have a question from Richard Golden here saying, do you have an online store for spare parts? We don't at the moment have a store where you can order them individually. This has been a requested thing. It's certainly something we will consider, but it hasn't been a particularly high priority for us. But if you are looking for things, reach out to our support team. We might have some spares that we might be able to sell you. So reach out to us and we can sort that out. We have a question from Casey. Will it be an option to get spare parts when available to be shipped from Toronto? I'm unsure right now of the country of origin of those parts, but we'll think about that one. Feel free to reach out to support and we can talk about that offline as well. We have a question from Jeremy Profit. Here's a big one. Are we ready? Support for coloring models.
Yeah, that's an exciting one. I can say that it's coming. I'm not going to say when, but look out for when we do. We have so many things planned for Canvas. It's going to be part of Canvas, at least for launch at the time being. But this is, for anyone that doesn't know what coloring means, it means taking a single bodied model like this and then applying color as you would in Photoshop or Illustrator to the areas that you want to have color in. So this is not something that exists today. The closest thing to that is it's a complex feature, literally called complex because it's so complicated, in a program called Mesh Mixer. So look out for that. It's on its way. You'll probably be learning more about that. I'm going to say Q2, maybe.
Ooh, Bobby.
Late. Okay, Q3. Let's
Q3.
say
Yeah. Q3. It will certainly be in 2019.
Exactly.
Yeah.
2020.
2020. No.
Well before 2020.
It's coming soon. There was a question about uploading firmware from the Pi.
Gotcha. Okay. I just wanted to address that question from KC about spare parts. It looks like in the chat, yes, those parts do ship from our Toronto office at the moment.
Bruce Ennis.
Gotcha. Okay. Yeah. So we have a question from Bruce Ennis. At some point, will I be able to do firmware updates from the Pi?
Yes, that is something that we're planning to add to our Octoprint plugin sort of portfolio. That way, when there's a new firmware update, if you have a connected experience set up where you've got a Canvas app connected to your palette, it's kind of annoying to disconnect the cables, bring something over to your computer. We're going to be adding a plugin to Octoprint so that you can update firmware without disconnecting any cables. You can just do it from the Octoprint interface. That will also, of course, be shared online as a plugin that you can install to a DIY hub if you so choose.
That'll make things nice.
Mm-hmm.
Awesome. Okay. Thank you very much, everyone, for the questions. I think things are cooling down in chat. Understandably, it's getting very late in EU and further east. So thank you so much. I think we're probably going to sign off now, but we do have lots of Mosaic team members around in chat. We'll have our team available to answer questions there as well. But that's all for now. And please tune in for our next live stream. In the meantime, if you have any comments, any feedback on how we can improve streams, please let us know, because we like these. We like being able to interact with people in real time. So I think we intend to do more of them in the future. So please let us know how we can improve. Thank you very much, and have a good night, everyone.